Hey guys, welcome to lesson number 9. This is day 2 of solving log functions. I want you guys to go ahead and do these two problems on properties of logs. So go ahead and pause your video. Once you're done with these two questions, unpause your video and the answers will be there. All right guys, here's the answers to these two problems. On the first one, make sure you have these parentheses here showing that this entire thing is in the denominator. Also here, make sure that you simplify log base 3 to the 9 to 2. And then over here, remember when you're multiplying the z to the fourth times this fraction, that z to the fourth goes to the numerator. All right, like I said, today we are going to continue on with solving logs. Okay, remember when we're solving logs, we're going to exponentiate both sides in order to cancel out the logs and to solve our problem. Today what we're going to look at is this part here when we have multiple logs, and when we do that, we have to condense everything first. So, case 2 of solving logs is when we have multiple logs, either one on each side of the equal sign or multiple on one side. So the first thing we're going to look at is this example here, where we have log equal to another log. If that's the case, both logs for these problems are going to have the same base. If that's the case, we're simply going to exponentiate both sides. Okay. Now, don't forget this hint here. Okay, make sure you check for extraneous solutions. Make sure, because you cannot log a negative number. You also cannot log 0. Okay, so make sure that you don't get a negative or a 0 inside the log when you plug it back in. So we get to this first example here. We simply have log equals log. And so what we're going to do is we're going to exponentiate this side. So we're going to take it 4 to this whole thing and 4 to the power of this whole thing. And so what that's going to do for us, the log base 4 and the exponential base 4 are both going to cancel each other out. And so this side is going to leave us with x plus 3. Same thing over here, log base 4 and exponential base 4 cancel each other out. Leaves me with 8x plus 17. From that point, all we're doing is solving this. This is just simply a linear. So we're going to subtract x, we're going to subtract 17, and we're going to solve that. So we're going to get x equals negative 2. So then the only thing we have to do is we just have to make sure that's not extraneous solution. When I plug it in here, I get negative 2 plus 3 is 1. That's good. Plug it in here, I get negative 16 plus 17. That's 1 as well. So we're good. Now on the second one, same thing. Okay, we have a log base 6 equal to a log base 6. And so all we're going to do here, again, exponentiate both sides with this base 6. What that's going to do, again, is going to cancel out log base 6, exponential base 6. Same thing here. It's going to leave us with this x squared equals 6 minus x. Now, again, all that is an equation we've dealt with before. Okay, it's just a quadratic. And so since it's a quadratic, I'm going to get everything on one side, and then we're going to solve using whatever method we want. So this one here is factorable. So we get x plus 3, x minus 2. So that gives me x equals negative 3, x equals positive 2. When I go back up, if I plug in negative 3 here, I get negative 3 squared, which is positive 9. Plug in negative 3 here, I get 6 plus 3, which is also positive 9. So that's a good answer. Plug in 2, I get 2 squared is 4. 6 minus 2 is 4. Both of those answers work. So when you plug answers back in here, it's pretty simple. You don't have to work the whole thing out. You're basically just making sure that you don't get that negative or that 0 inside of the log. The second type of problems we're going to look at are these problems here that have multiple logs on one side. Okay, so it says if multiple logs or more than 2 terms total, condense first, then exponentiate. So what we're going to have to do here is we're going to have to do one step to make the problem look like this, to make it look like the ones we just did. So we're going to have to condense these multiple logs together first, and then it'll be log equals log, and so we'll be able to exponentiate. So first thing I'm going to do here is I'm just going to look at this left side. I'm going to leave the right side as is, log base 4 of 3. And so first thing we're going to do is we're going to condense this. Well, it's subtraction. So we know that we condense subtraction by using division. And so it's going to give us log base 4 of x plus 5 over 2x. Okay, now it's just like the problems we just did. So now once we get here, log equals log, we're simply going to exponentiate it on both sides and then solve from there. So just like we just did, the log and exponential are going to cancel each other out. I'm going to get x plus 5 over 2x on the left side. I'm going to get 3 on the right side. Okay, and then we're just going to solve it from there. So I need to get rid of the denominator here. So I'm going to multiply both sides by 2x. That's going to give us x plus 5 equals 6x. Now it's just a linear. Now we can solve that. So we get 5 equals 5x, which gives me x equals 1. We just have to make sure when we go back up that doesn't give us negative or 0 inside. It'll give me 6 here. It'll give me 2 here. So that is a good answer. Example 4, same thing. I have multiple logs on this side here. So I need to condense those first. So we're using addition, so we know that's multiplication. So log, remember this is base 10. So 2x times x minus 5. If you want to go ahead and distribute that in, you can. Leave the 2 alone. Now I just have that log on that one side, so now I'm just going to exponentiate both sides. Again, this is base 10. So it's 10 to the log 2x x minus 5 equals, we have to exponentiate this side as well, so it becomes 10 squared. So these cancel. I'm going to go ahead and distribute this in. So we get 2x squared minus 10x equals 100. Now all this is a quadratic, and so again I'm just going to get everything to one side and I'm going to solve from there. So we get 2x squared minus 10x minus 100. We have a GCF of 2 here, so I'm going to go ahead and pull that out. And now we see if we can factor that. So we can. X minus 10, x plus 5. And so that's going to solve out to x equals 10, x equals negative 5. And so all we have to do from there, check our work. So we got 10 and negative 5. If I plug in 10, I'm going to get 20 here, 5 here. So 10 is good. If I plug in negative 5 right here, that's going to give me log of 2 times negative 5, which gives me log of negative 10. Since we get a negative inside the log, that doesn't work. Okay, and so again, that's all we're looking for when we're checking for extraneous solutions, is if we get that negative inside the log. All right, I want you guys to try these 3 examples. So go ahead and pause your video, work out these 3 examples. When you're done, unpause the video and you'll see the 3 answers. All right, once you are done, you should see these 3 answers. Check your work, make sure you have everything right. If you have any questions, let me know. Proceed on to lesson number 9, practice problems.